Okay, today this is the third part of inverse trigonometric functions. Today we are going to do the miscellaneous examples and exercise based on that. So you have the example 11 now. Let us prove that sine inverse 12 by 13 plus cos inverse 4 by 5 plus tan inverse 63 divided by 16 is equal to pi. Sum of all these things should be pi. So I need to get tan inverse x plus tan inverse y forms here. But I have only sine inverse and cos inverse, so I need to convert it into tan, and hence I have pi also. From where that pi has come, I don't know, so I need to check now. So I'll find the sum of these two. This comes to be sine inverse 12 by 13 plus cos inverse 4 by 5. I'll convert it into tan by taking the Pythagorean triangles. Okay, now we have opposite by adjacent. Here it is. Opposite by hypotenuse is adjacent by hypotenuse, considering these two angles, this as the same angle. So now this comes to be a Pythagorean triplet here. So this is 5, 12, 13. So the tan inverse comes to be 12 by 5 and plus this is tan inverse 3. This is the Pythagorean triplet 3, 4, 5. So this comes to be 3 by 4. Okay. Now I need to find xy. If xy is less than 1 only, I can use that form, that is tan inverse x plus tan inverse y. So what is 12 by 5 into 3 by 4? So this is 3. So this is 9 by 5. 9 by 5 is greater than 1. So directly we cannot use that tan inverse x plus tan inverse y form. So what it is going to be is, so let us take the first term to be a and the second term to be b. So I'll find tan of a plus b, that is 12 by 5 plus 3 by 4 divided by 1 minus 12 by 5 into 3 by 4. Tan a plus tan b divided by 1 minus tan a tan b. So what I'm going to get here is, this is 36 plus 15 divided by 20 minus 36. Okay, this was not 36, this was 48. 48 plus 15 divided by 20 minus 36. What you are going to get here is, there is going to be a negative sign here. 20 minus 36 comes to be minus 16. So 8 plus 5 is 13. 3. 1 is carried. 4 plus 1, 5 plus 1, 6. 63 divided by 16. So you can understand that tan of something is negative. Okay. Tan inverse of tan a plus b is equal to how much? That should be equal to tan inverse of 63 minus 63 by 16. So but I cannot directly tell this is to be equal, because this is more than, this is negative here. So okay, let it be. Let us just leave it at here. Therefore a plus b is equal to tan inverse minus 63 divided by 16. Okay, now you have the right hand side. I'll rub this off. Right side may not be the right hand side. Right hand side is only pi over there. So I'll consider pi minus tan inverse 63 divided by 16 to be the right hand side. So since this is positive, I can convert it into cot. So this becomes pi minus cot inverse 16 divided by 63. So pi minus cot inverse is cot inverse of minus 16 by 63. Okay. So a plus b is equal to tan inverse of minus 63 by 16. And this comes to be, or instead of making these things, let me leave it to be like this itself. So this is equal to minus tan inverse 63 divided by 16, or pi minus tan inverse 63 divided by 16. Because it is not always in the case, tan is going to repeat again and again by pi. Since you can understand that all these are going to be positive, therefore the sum of these two cannot be negative. It cannot be minus tan inverse. So this case is avoided in this case. So pi minus theta is also similar to minus theta, because tan of pi minus theta is minus tan theta, same thing. So instead of making this many things, I can just tell that pi minus tan inverse 63 by 16, that is the sum of the first two, plus tan inverse 63 by 16 comes to be pi. So this was the sum of these two, pi minus tan inverse 63 by 16. Therefore, sin inverse 12 by 13 plus cos inverse 4 by 5 plus tan inverse 63 by 16 is equal to pi. You are going to bring this to the left hand side, that's it. Now I need to explain why this is. I feel that you didn't understand, so I'm going to explain this once more. You are getting tan inverse of tan of a plus b. So tan of a plus b was minus 63 by 16. So taking tan inverse on both sides, so this and this is going to get cancelled. So you get a plus b. A plus b is equal to tan inverse of this thing. So directly maybe it is not like this. So tan inverse of minus 63 by 16 comes to, it has to be pi minus pi plus tan inverse 63 by 16, because the sum of these two is always, it is going to be greater than it's going to be positive, it cannot be negative. So if you have only this term, that is tan inverse minus 63 by 16, the answer you get is sin inverse of a positive and a cos inverse of a positive is negative. How it can be negative? Cos inverse is always positive and sin inverse, so since this is positive, this value is positive, sin inverse of that also comes to be positive, therefore it should be always positive. Hence, since tan is periodic by pi, so I added a pi so that it becomes easy for me. So it becomes pi minus like this, so you get the answer. Okay, now we have the next example. The next example is example 12. You are asked to simplify the given thing, that is tan inverse, always that comes to tan inverse a cos x minus b sin x divided by b cos x plus a sin x. So one of the questions in exercise 2.2, it was like cos x minus sin x divided by cos x plus sin x, but here you have a, b and so many terms like that, so irritating things. So better I'm going to divide by some common thing. So maybe I'll divide in numerator and denominator. Divide numerator and denominator by b cos x. Let me divide by b cos x, so that may become easy. B cos x, so this becomes tan inverse a by b. Cos x and cos x is going to get cancelled, and you have minus b and b is going to get cancelled. You get tan x divided by, have b and b is going to get cancelled, cos x and cos x, so 1 is remaining. Then you have plus a divided by b, sin x by cos x is tan x. So this is a term. So what are you going to get here? So this is tan inverse of tan inverse a by b, tan inverse a by b minus x. Now this tan inverse and this tan inverse is going to cancel. So what is this? How did I take this tan inverse a by b? This is tan a minus tan b divided by 1 plus tan a tan b. That is the form I got. So I consider tan a to be a by b. Therefore that angle a comes to be tan inverse a by b. And the second part is, however, directly x. So directly we got that. So tan inverse and tan you are going to get cancelled. So you have tan inverse of a by b minus x to be the answer. Next we'll move on to the exercise, that is the miscellaneous exercise in chapter 12. The first set of questions is about the finding the value based on that given thing. Okay, you have the miscellaneous exercise. Now the first question is cos inverse of cos 13 pi by 6. So this is not going to be in between the 0 and pi. it is more than pi here. So it is okay, let me turn in terms of pi. I can write that is 12 pi by 6 plus pi by 6. 12 pi by 6 is 2 pi plus pi by 6. So every trigonometric function has at least a period of 2 pi. So tan has a period of pi. Here you have a period of 2 pi. Period, I mean it is going on repeating again and again after an interval of 2 pi. So that 2 pi I can cancel off. So because it is just a period, so it is going to repeat again and again. So this is going to be cos inverse of cos pi by 6 itself. That is equal to pi by 6. Okay. Now we have 7 pi by 6. 7 pi by 6 can be written as pi plus pi by 6. Pi plus pi by 6. Since tan has a period of pi, it is going to be repeating every pi. So this is coming to be tan inverse of tan pi by 6. That is equal to pi by 6. Okay. The next set of questions is about proving. Prove that. So the third question is 2 sine inverse 3 by 5 is equal to tan inverse of 24 divided by 7. The question is 2 sine inverse 3 by 5 is equal to tan inverse 24 by 7. So for easy calculations, better you have 2 tan inverse x instead of having 2 sine inverse x. Or you need to use a bigger formula. You get tan, sine, cos, and all those things. 2 sine theta cos theta, that becomes very long and irritating. So better I'm converting it into tan. For that I need to take the Pythagorean triplets. So this, if you consider this to be the angle, this is 3 and this is 5. Therefore this becomes 4. 3, 4, 5 is a Pythagorean triplet. That is very known. So this becomes 2 tan inverse 3 divided by 4. 3 by 4 is the LHS. LHS turned to be like this. Okay. Now 2 tan inverse x is, now we need to consider in the tan inverse form, or as 2 into x, 2 into 3 by 4 divided by 1 minus 3 by 4 whole square. Okay. What is this 3 by 4 whole square? And so many things you are going to get. This is tan inverse 3 by 2 divided by 1 minus 9 by 16. Okay, now you have now tan inverse of 3 divided by 2 divided by 16 minus 9. 16 minus 9 comes to be 7. 7 divided by 16. 2 and 8 I'm going to get cancelled. So 8 I'll go to the numerator now. So this comes to be tan inverse 3 into 8 is 24. And you have 7. Tan inverse 24 by 7, that comes to be the right hand side. Okay. Now we have the fourth question. The fourth question is sine inverse 8 by 17 plus sine inverse 3 by 5. 3 by 5 is equal to tan inverse 77 divided by 36. The question is sine inverse 8 by 17 plus sine inverse 3 by 5 is equal to tan inverse 77 by 36. This is going to be like the previous one itself. You are going to convert it into tan. So this should be some tan inverse, and this is also tan inverse. As the previous one I found out, it was 3 by 4. Okay, this was LHS, right? So Pythagorean triplet says 8, 15 and 17 are Pythagorean triplets. So you have 8 and 17. 8 is the opposite side, therefore 15 becomes the adjacent side. So 8 by 15. I hope you know the Pythagorean triplets. That's very easier to calculate rather than going on doing big things. So you have tan x plus tan y. Their product is however less than 1. No need to worry. So this becomes tan inverse of first plus second 8 by 15 plus 3 by 4 divided by 1 minus 8 by 15 into 3 by 4. Okay, now what is this? This is tan inverse of 8 into 4 is 32. and 15 into 3 comes to be 45. 15 into 3 is 45. Now we have 15 into 4. 15 into 4 is 60. 60 minus 8 into 3 is 24. What you are going to get here? Here this is tan inverse 77 divided by 60 minus 24 is 36. That is the right hand side. Okay. Now we have the fifth question. Fifth question is cos inverse. So this is a different one, not like the previous ones. Cos inverse of 4 by 5 plus cos inverse of 12 by 13, it should be equal to cos inverse of 33 by 65. 33 by 65, that was the thing. So by finding that the right hand side is cos inverse, so we need to find the cos of these two. Okay, so let me consider this is A, and this is B. Then what is sine A and what is sine B? That is, first of all I need to find out, and then I can apply the cos of A plus B form. So this is a Pythagorean triplet again. So what you're going to get, sine A to B is 3 by 5. I'm not going to write that again. So this is cos inverse of that. So by taking the Pythagorean triplet, you'll get sine A is equal to 5 by 13. So what is cos of A plus B? Cos of A plus B is cos A cos B minus sine A sine B. That is the thing what you're going to get. So just write this. That is 4 by 5 into 12 divided by 13 minus 3 by 5 into 5 divided by 13. 5 and 5 is cancelled. Okay, what you're going to get here is, or maybe I need not cancel that. I'll take 65 as common here. 12 into 4 is 48 minus 15 is what you're going to get. So 65. So however you need to get 33. We'll check whether it is 33. 4 minus 1, 3. 8 minus 5 is also 3. 33 by 65. Therefore A plus B is equal to cos inverse 33 by 65. Hence proved the given statement. Now we have the sixth question. Sixth question is similar to this, but you are asked to find the sine of those two. Okay, since it is sine, I'm just going to skip that question. So the next question is tan inverse of 63 by 16 is equal to 5 by root 3, 5 by 13 plus cos inverse 3 by 5. How we are going to get that? Tan inverse 63 divided by 16 is equal to sine inverse of 5 by root 3 plus cos inverse of 3 by 5. Okay, this was the seventh question. So now we need to take the right hand side and come to the left hand side. So we need to take the tan of the right hand side. So for converting that one into tan, all the questions given in this exercise are based on the Pythagorean triplets. You have 5 and 13, so 12 is the other one. Therefore the tan inverse of that is going to be 5 by 12 plus cos inverse, it's not cos inverse, it's tan inverse, right? Tan inverse of which number? Tan inverse is opposite, but 3 is adjacent side, so 3 is in the denominator. Its other side is 4, so it comes to be 4 by 3. Okay, so this much we got. Now we need to find tan of x plus y. This was a similar question, right? This was a completely similar question we already done, so directly we'll get this. Okay, now we have the eighth question. Eighth question is a series of so many tans. You are asked to find tan of 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8. Those four you are asked to find out and tell that it is equal to 1. For that, directly I'll take these two. So this comes to be tan inverse of first plus second, so it comes to be 12 divided by 30. 7 into 5 is 35. 35 minus 1 is 34. 12 by 34. And you have tan inverse 1 by 3 plus 1 by 8. So what is the product you are going to, the sum you are going to get is 8 plus 3, 8, 9, 10, 11. So 11 is the numerator. So what will go into the denominator is 8 into 3 minus 1. That is 24 minus 1, that is 23. So we need to add this again now. This comes to be tan inverse of first plus second. That is 12 by 34 plus 11 by 23 divided by 1 minus 12 by 34 into 11 by 23. This is however going to be a very big number. At last you are going to get tan inverse of 1, that is equal to pi by 4. Okay, you have the ninth question. Here it is given you are asked to prove that tan inverse root x is equal to half of cos inverse 1 minus x by 1 plus x. So there is a given condition, x is belonging to 0 to 1. 0 to 1 means it is going to be some positive number only. So this is of the form 1 minus x by 1 plus x. So since it is not tan inverse, I cannot convert it into pi by 4 plus x over there. So instead I need to convert it into 1 minus tan square theta divided by 1 plus tan square theta, that comes to be cos 2 theta. So let me take the right hand side and let x is equal to tan square theta. Tan square theta. So what it is going to be? Half of cos inverse 1 minus tan square theta divided by 1 plus tan square theta. That is going to be cos 2 theta. Therefore it is half into 2 theta. 2 and 2 is going to get cancelled, you get theta. From substitution you can find out that tan square is equal to x, therefore tan theta is equal to root x. Tan theta is equal to root x, therefore theta comes to be tan inverse root x. Tan inverse root x, that is the right hand side. Okay, since there is no substitution extra over here, I can directly start with the simplification. For simplification, I have a plus b divided by a minus b. Since there are root terms, it's simpler for after rationalizing only, I think. So it is going to be, I need to multiply it by the conjugate of the denominator. So I need to multiply by root of 1 plus sin x plus root of 1 minus sin x divided by same thing, that is 1 plus sin x plus root of 1 minus sin x. How it is going to be now? So this becomes cot inverse of, now this comes to be a plus b whole square form, that is a square plus 2ab plus b square. So what is going to be the terms here? That is 1 plus sin x, that is a square, what is b square is 1 minus sin x, and 2ab, that is plus 2 into root of 1 plus sin x into 1 minus sin x is 1 minus sin square x divided by, then you get the a minus b into a plus b, that is a square minus b square form. A square is 1 plus sin x minus of 1 minus sin x. Okay, just by cancellation and all, you get this is cot inverse of 2 plus 2 root of 1 minus sin square x is root of cos square x. Cos square x, again root, comes to be cos x. So this comes to be 2 cos x divided by 1 and 1 is getting cancelled. So this comes to be 2 sin x. Therefore this is equal to 2 and 2 will get cancelled. This becomes cot inverse of 1 plus cos x divided by sin x. So this was similar to the previous one. So this comes to be cos square x by 2 divided by 2. When it is sin 2 theta form, it comes to be sin x by 2 cos x by 2. 2 and 2 get cancelled. So what is common out of that is cos x by 2. So what is remaining is cos x by 2 divided by sin x by 2. That comes to be cot inverse of cot x by 2. That is x by 2, that is the right hand side. Okay, hence proved. This is direct, and there is no thinking of substitution also. Directly we can just find out that. The 11th question is about tan inverse root of 1 plus x minus root of 1 minus x divided by root of 1 plus x plus root of 1 minus x is equal to pi by 4 minus half cos inverse x. There is a hint given in the textbook, put x is equal to cos theta. Okay, applying that, I'm going to skip many steps in between because I think you know everything, most of the things. There is 1 plus cos theta root of 1 minus cos theta divided by root of 1 plus cos theta minus root of 1 minus cos theta. Okay, here it is plus, right? So 1 minus 1 plus cos theta is 2 cos square theta by 2. So everywhere root 2 is going to get cancelled. At last what you are going to get is here cos theta by 2 minus sin theta by 2 divided by cos theta by 2 minus plus sin theta by 2. At last, after dividing by cos theta by 2, you will get 1 minus tan theta by 2 divided by 1 plus tan theta by 2, that is equal to tan inverse of tan pi by 4 minus theta by 2. Therefore it is pi by 4 minus half theta minus half theta. Theta is cos inverse x. Therefore it is pi by 4 minus half cos inverse x. That was the answer you are going to get. Okay, now we have the 12th question. 9 pi by 8 minus 9 by 4 sin inverse 1 by 3 is equal to 9 by 4 sin inverse 2 root 2 by 3. Okay, this was the thing you got in this question. So just by seeing that this question is big, made big, but it is not so. You have 9 cancelled, you have 4 and again 1 4. Therefore the question is simply you are asked to prove pi by 2 minus sin inverse 1 by 3 is equal to sin inverse 2 root 2 by 3. That is very simple. Pi by 2 minus sin inverse 1 by 3, you are going to get cos inverse 1 by 3. That cos inverse 1 by 3 you are going to draw the triangle. So it becomes adjacent is 1 and hypotenuse is 3. So this is root of 9 minus 1, that is root 8. Root 8 is 2 root 2. Therefore the sine of that angle comes to be 2 root 2 by 3. Okay.